Okay, this video coincides with the PDF, the handout on arithmetic and geometric series, so you might want to print that out and follow along with that and certainly work through these problems with a paper and pencil. And I'm going to break this up into a couple of separate videos, so I'm not talking more than 10 minutes at a time. So the warm-up, of course, the last topic was sequences. And so we're going to continue if you look at the warm-up. So take a minute, think about it, hit the pause button on the video. But the sequence here is that we multiply by 2 and then add by 2. If I blow this up a little, this is a multiply by 2. And then from 2 to 4, we add by 2. And then we multiply by 2, add 2. Double it, add 2, double it, add 2. And if you continue on, the next three terms are going to be 92, 94, and 188. So a little bit tricky. It was kind of a combination of an arithmetic and geometric sequence. Now the next one, you can look at this forever and not get it. But the next three terms are 28, 45, and 90. And guess what this is? This is the number e, where e was that constant we learned about, was the base of the natural logarithm. E was 2.718828459045, and actually kept going on forever. So certainly that was tricky. That was taking two digits at a time, the digits of E. Okay, so what's a series? All it is a sequence with plus signs. We put plus signs in between instead of commas, and then we add them up, and a series is given away by what's called sigma notation. You've probably seen notations. That's a capital sigma, Greek letter sigma. And the numbers below and above the sigma are called your index. And to the right is the rule. It's the explicit formula of a sequence. So basically, what do? You start at 1, you plug 1 in. If I plug in 1, I get -4. And then I plug in 2, and I plug in 3, and I plug in 4, and we add up the terms. So if I plug in 2, 3 times 2 is 6, minus 7 is -1. So I'd actually add a -1, which of course is subtracting 1. If I plug in 3, the third term would be 9 minus 7, that would be 2. And basically I think you can see the pattern here. You know, the slope of this is 3, meaning I add every 3. I add 3 every time. So it's next one would be 5, and then 8, and then 11. And here's the thing, how far do I go? I go all the way to infinity. So I have an infinite, this is what's called infinite series. And guess what? If we tried to add that up, what would it add up to? It would add up to infinity. Another word for that is we would say the series diverges. And generally, if you have an arithmetic series, it's going to diverge because eventually things get bigger and bigger and bigger. Okay. So, of course, the only interesting ones as far as getting an answer to an arithmetic series would be a finite series. So number 2 is an example of that. You could see the index goes from t equal 1 to 5. So there'll be 5 terms. Same thing, we're just going to plug in t equals 1, t equals 2, t equals 3, 4, and 5. If you plug in 1, you get 7. You plug in 2, you get 11. You could probably see the pattern. You're just adding 4 every time. And then finally, if you plug in 5, you get 23. And if we add these up, we get 75. Okay. All right, if you look at number 3, we're going to add up cosine of n pi from 1 to 4. So we're plugging in 1, 2, 3, and 4. I bet you thought you were done with trig, huh? So I got cosine of 1 pi, cosine of 2 pi, cosine of 3 pi, and cosine of 4 pi. And I have to fix that. Of course, it's a series, so we're adding these up. And at pi, the x value is -1. At 2 pi, it's +1. At 3 pi, you're back over at 180 degrees. You're at -1. And at 4 pi, you're right back at same as 0. So that would be +1 would be the x coordinate, the cosine value. And this one zeroes out. So you could do all this sequence and series things with trigonometry. Finally, number 4, we have factorial. We don't talk too much about factorial. You get into it a little bit in probability class or statistics class. A couple things to notice. The index here didn't start at 1. It doesn't have to. Normally it would start at 1 or 0. Here it started at 2, and it went from 2 to 5, so that's actually going to be 4 terms. Although it's not in parentheses, it's kind of understood that, you know, that's our explicit rule there. It's that sigma doesn't just go with 4. Okay, so we would have 4 plus 2 factorial, and we'll add that to 4 plus 3 factorial, 4 plus 4 factorial, and then 4 plus 5 factorial. And of course, factorials, by the way, they're on your graphing calculator under math probability. You can find it, but factorials just multiply out successive integers. I'll give you a quick example. 4 factorial would be 4 times 3 times 2 times 1. So 4 factorial would be 24. It adds up integers less than or equal to the number you start with. So real quick, 2 factorial is 2. 3 factorial is 3 times 2, that's 6. 4 factorial we just saw was 24. And 5 factorial is 120. And if we add all that up, we get 168. Okay, we'll continue.